Hi there. I'm doing a quick review here of factoring by a difference of squares. And before we jump right into it, I'd like to always take a step back and see where does this come from. So this comes from a case where we are asked to expand something that is like this: x plus 2y times x minus 2y. So in this case, the question would say expand and simplify, or expand using FOIL. But this is a special case because these two brackets are identical, except one's a positive and one's a negative between them. So in a case like this, when we FOIL, we get something a little unique that happens. So we go x times x and we get x squared. We go x times negative 2y and we get negative 2xy. And then we go inner 2y times x, which is positive 2xy, and 2y times negative 2y, which is minus 4y squared. And when we simplify and combine our like terms in the middle, the negative 2xy plus 2xy gives us 0xy. So that those two terms in the middle just cancel each other out, and we're left with x squared minus 4y squared. So what we're reviewing today is what happens if we're given a question like x squared minus 4y squared, and the instruction is either factor by difference of squares if your teacher's being nice and telling you which method to use, or if it's a more general question, would just say factor fully. So I look at this, and the first thing I always want to check is, can I common factor it? And in this case, there's no common factors. And it's not a trinomial, so I can't do trinomial factoring. But I look, it's a binomial, it's two terms, and there's a minus between them. So it's a difference, and they're both perfect squares. So the question is, how do I work backwards? And an in-between step that you don't need to do, but which is sometimes helpful at first to sort of get my head around this, is I say x squared is like x being squared, and then minus 4y squared is like 2y being squared. That'll give us a 4y squared. So my difference of squares, my squares are x and 2y, and it's a difference of squares. And the rule is we just make our two brackets, and it's as simple as this. It's always just the first term, x, plus the second term, 2y, and then the first term, x, minus the second term, 2y. So let's look at a couple more examples. So let's say we have 9x squared minus 25y squared. If you think you've got it, just pause the video a second and see if you can do this yourself. So I look at my two factors and I say, what's being squared? That'll give me 9x squared. And I say, 3x. So I go 3x inside my brackets and 3x. And then I say, what's being squared in the second term? That'll give me the 25y squared. And I say, oh, 5y. So it's going to be plus 5y and minus 5y. So let's look at a couple curveballs that can be thrown at this. So first, what if we have like 32x to the 4 minus 18y squared. So first of all, 32 is not a perfect square, and 18 isn't either. And second of all, this one has an x to the 4, and this one has a y squared, so it's not exactly the same. So step number one, always, if I can common factor, I do. So I look, are there any common factors? And I say, oh yeah, 2 goes into both those numbers. So step one, pull out that 2. When I pull out the 2, I've got 16x to the 4 minus 9y squared. Okay, so that's looking a little better because 16 is a perfect squared and so is 9. So now the question is, what's being squared here to give me 16x to the 4? And the answer is, what's being squared is 4x squared, because 4x squared times 4x squared gives me 16x to the 4. So in the front of each bracket, I put a 4x squared. And a 4x squared. And now I say, okay, what's being squared to give me 9y squared? And it's, 3y. So this becomes plus 3y and minus 3y. So there's one more type of example I want to show you a case of, just because it sometimes turns up. It's ugly. I don't particularly like it, but I'll show it to you anyway. So what if we get something like 49x squared minus 10? Now, sometimes you'll see an instruction that says factor, and it's like, this is a pain. So in this case, I say, okay, what's being squared to give me 49x squared? And the answer is 7x. So 7x and 7x. But I say, what's being squared? That gives me the 10. And the answer to that is the square root of 10, because the square root of 10 times the square root of 10 equals 10. So this isn't one I like to do, but sometimes it's relevant and comes up. So square root of 10 is my perfect squared here. So it becomes 7x plus root 10, 7x minus root 10. So again, it's a little bit of an ugly example, but it does occasionally come up, and I thought it'd be worth including in this. So I hope that refreshes your memory of difference of squares, and good luck studying for your exams.